Welcome to Lesson 3.1, Powers and Exponents. Today we're going to talk about how to convert numbers from exponential form to standard form, and then from standard form to exponential form, how to simplify expressions with exponents, and how to identify the parts of a number in exponential form. Alright, so first and foremost, we have lots of vocabulary today because in order to work with exponential form and exponents, we need to know what an exponent is, what a base is, and power, squared, cubed, all these wonderful words that you're going to hear quite often in your math career. So the exponent tells how many times a number is multiplied when written in exponential form. Okay, and you can also put a little side note here. It's the small number. Okay, the definition isn't that it's the small number, it's just a helpful reminder that it is the small number. Okay, the definition tells you what the exponent does, and in this case, the exponent tells how many times the number is being multiplied when you're writing it in exponential form. So in this case, the 4 is the exponent. The 4 tells us that the 3 is going to be multiplied 4 times. Okay, and then the base is the number being multiplied when written in exponential form. Okay, and you can also put a little note here, it's the big number. So in 3 to the 4th power, 3 is actually the base. So the exponent tells you how many times it's being multiplied, the base tells you what you're multiplying. Power. So power is a number that can be expressed using an exponent. So what this means is 8 would be a power, because 8 is a power of 2. So if you take 2 times 2 times 2, or 2 cubed, you get 8. So 8 is a power of 2. Squared, when a base is to the second power. So when you hear us talk about something squared, 5 squared, 10 squared, we're talking about a number raised to the second power. So it's that exponent being 2. You only use the word squared when your exponent is 2. And we'll see how this is related to area later on down the road. But when you take length times width of a square, you're taking the same number times itself. So they're interrelated. And then cubed. Cubed is when a base is taken to the third power. So look at it this way. A square is a 2-dimensional shape, and it's to the second power. Cubed is a 3-dimensional shape, and so it's being taken to the third power. Okay, so cubed we talk about when we talk about volume because it gives us length, width, and then adds that third dimension of depth. Okay, so like I said, all of these words are going to be used throughout your mathematical career. I don't expect you to have them mastered by the end of this video, but I want you to be getting used to using them and hearing them because you have to be able to identify what they are in order to be successful. Alright, so when we look at this problem, 2 times 3, what does that actually mean? Well, we know that multiplication is actually repeated addition. So 2 times 3 actually means 2 plus 2 plus 2. Because let's face it, we like to take things that are really long and make them as short as we can. So what happens when we have a problem? And I'll write this down. And it's repeated multiplication. So let's say now that I have 2 times 2 times 2. Can I make this shorter? Well, if you look at your definition of exponents and bases, it tells you that the exponent tells you how many times a number is being multiplied, and the base tells you what number is being multiplied. So in this case, your number has to be the same. So it has to be repeated multiplication of the same number. Because we couldn't say, like, if we had 2 plus 2 plus 2 plus 5, we couldn't say that that's 2 times 4, because that 5 is actually different. Okay, so we have 2 times 2 times 2, which is repeated multiplication because you're repeating the same number. So our base is going to be 2 because that's what's being multiplied. And our exponent, since the exponent tells us how many times it's being multiplied once, twice, 3 times. So our exponent would be 3. So exponential form is where we take the base and the exponent and you put them together. So you have your base of 2 and your exponent of 3. Right, so we're going to take these problems and we're going to go ahead and put them into exponential form. So you have your base, in this case, is the number that's being multiplied, so your base is 4. And your exponent, well, it's being multiplied 1, 2, 3 times, so your exponent would be 3. So your exponential form would be 4 to the third power. Okay, so here, our base, the number that's being multiplied repeatedly, is 3. Our exponent, well, it's 1, 2, 3, 4, 5, 6. It's being multiplied 7 times, so our exponent would be 7. So our base is the big number, and our exponent of 7 is the little number. Okay, so now if we're working backwards, if we know that 2 times 3 means 2 plus 2 plus 2, we can go backwards. We were able to go from, so this is standard form, and we went from standard form to multiplication. Now we were able to go from standard form to exponential, but now how do we go from an exponent, so a number in exponential form, to standard form? Well, we have to remember the base tells us what is being multiplied. So the base is 2 and the exponent is 3. So that tells us that 2 is being multiplied 3 times. So I have to have 2 3 times. So 2 times 2 times 2. Okay, so the number you're using, you use or multiply, and how many times you multiply it. Okay, so let's try one on our own. So we have 2 to the 6th power. So since the base is 2 and the exponent is 6, that tells us that I need to have 2 and I need to see it 6 times. And so I need to have 6 of them. So 2, 2, 2, so that's 3, 4, 5, 6. And I know it's repeated multiplication, so I have to put my multiplication signs in. 5 to the 2nd power tells me that my base is 5. My exponent is 2, so I need to multiply 5 2 times. Okay, so these numbers, when they're in exponential form, they have the different pieces that we've been identifying. So if we take any number in exponential form, so let's take 7 to the 58th power. Doesn't even matter how big they are, or if it's a decimal or a fraction, it's all the same. You have to be able to identify the pieces. So I know that 7 is my base, and 58, the small number, is my exponent. Okay, so we're going to use a bit of a smaller number here, and I'm actually going to do this with a fraction, so don't get overwhelmed, just watch what goes on. So if I have 3/4, and I'm taking that all to the 3rd power, that gives me 9 over 64. Okay, because remember, 4 to the third power means 4 times 4 times 4, and 3 to the third power means 3, times 3 times 3. So it's actually not 9, it's 27. So it's easy to make that mistake of doing 3 times 3 and 4 times 3, but you know that 3 times 3 is 9, times another 3 is actually 27. 4 times 4 is 16, times 4 is going to be 64. So now we've added this piece right here, we've added the answer. So this is still your exponent. 3/4 is still your base. So the whole thing, 3/4 is your base. And then 27/64 is your power. Okay, and no worries, we're not going to dig into fractions just yet, but I want you to be aware that when we're working with exponents, that it does involve fractions. Okay, so here let's identify the different pieces. So the base is 3. The exponent, or the tiny number, again is 3. And then the power is 27. So 27 is a power of 3. And make sure to write that down so you get used to that statement. So here we have a base of 7. Again, we have an exponent of 3. And then we have a power of 343. So 343 is a power of 7. So your power is always a power of the base. Okay, so whatever the answer is, you can say that's a power of whatever the base is from that exponential form. Okay, and then we're going to pull this into an actual problem. So we have Maria, who won a grand prize on a game show. She's going to be given $2 the first month, 4 the second, 8 in the third, and so on and so forth. So every month her payment is getting doubled. So let's look at this. So in 1 month she gets $2. In 2 months she gets $4. In 3 months she gets $8. Let's look at what's happening here with exponential form. So here, when you have $2 in that first month, you have just 2. But then now you're doubling the earnings. So to go from 2 to 4, you're multiplying by 2. So this is actually 2 times 2. And then you're multiplying again. So to get the 8, you took 2 times 2 times 2. So then now you have the 4th month, where you know that in order to get your next amount, you have to multiply by 2, and that's going to give you 16. So now you've multiplied 2 4 times. Well, we know with exponential form that we can make repeated multiplication shorter. So 2 to the second power would replace 2 times 2. And notice that it's the amount of money you started with, and your exponent is the month. So the third month, you multiplied 2 3 times, okay? 1 for each month that you got it, so you're taking 2 to the third power. And in the 4th month, you multiplied 2 4 times, so you're taking 2 to the 4th power. So we want to know how much money will she get in the 10th month. Well, we know in the 10th month we have to continue to double everything, so we'll actually have taken 2 times itself 10 times. So in that 10th month, we know that we can do, instead of writing out all these times 2's, we can just take 2 to the 10th power. Okay, so if we take 2 to the 10th power, we can say that that's how much money she earned. And then you can actually, or I shouldn't say earned, that's how much money she won. Then you can actually take that and continue to multiply it out. So taking 2 times 2 times 2 times 2 times 2 10 times. And to do that, it would take us quite a bit of time. So what we're going to do is I'm just going to give you the answer. My concern is that you can just turn it into exponential form. So in that 10th month, she would earn $1,024. So I want you to be able to tell me how much she would earn altogether. If you want to know how much she would earn altogether, we would have to put together each of the months. And we will talk about that more in class. But at this point, what you should be able to tell me is, what would my exponential form be for any month? Okay, so what would that look like? All right, so you have a couple of U-try problems. You're converting from standard to exponential and exponential to standard. You're identifying the parts. I want you to give me an example of a number being squared and an example of a number being cubed. And then you also have a word problem here on the back that I would like you to try to put together an expression in exponential form. I know that this can be tough and we always go through everything in class, so please make sure that you give it a shot. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.